Today we will be doing lab 4. This lab will be on interference and diffraction. This corresponds to the module 1.5. What we'll be doing today is first define interference and then define diffraction, and we'll show what's the distinctly difference between these two things, and then we will show how to calculate either the wavelength or the distance between the slits in the case of interference, and either again the wavelength or the diffraction grating constant. We'll find out that using the wavelength. The reason I said this one is because we're going to use a helium neon laser. So once we use a helium neon laser, we know the wavelength of the helium neon laser, which is not a difficult thing, 632.8 nanometers. So it will be interesting to calculate. But if you know the distance between the slits, we can calculate the wavelength also. So let's start. Let's first define interference. Interference happens when specifically two waves of the same wavelength are combined such that their phases are either in phase or out of phase. In phase means that these two phases are exactly the same. Out of phase means that these two phases are 180 degrees apart. And we would also like to say later on that this interference is totally different from diffraction. So first we will go a little bit about understanding how the interference pattern looks like. For example, if you see that the interference pattern will be having exactly equal intensity of all the fringes, unlike in the case of diffraction, where you have the central order or the 0th order will be the most intense, and as we go further down in the orders, intensity will go down. Another important thing to notice is that diffraction can exist by itself, but interference can never exist by itself. It has to be always accompanied by diffraction. This is the interesting thing. If we now look at the slide, we have three pictures here. The first one shows that there are two waves. These are exactly in phase. They have the same wavelength and they are also in phase. And because of this, we'll have constructive interference where the intensity will be multiplied. That is, it will be double the intensity of each one of them. And the other one, you can see this is the diffraction, this is the out of phase waves, wherein you can see that these are completely out of phase. They are 180 degrees apart. So therefore, they will create destructive interference. Therefore, we get dark bands. Whereas the third one shows there is a jumble of waves. There is no phase relationship at all. Therefore, you don't have any interference at all. This is the actual picture of the interference. This shows that there are two slits here. This is incidentally called the Young's double slit experiment. And in this, if you take a laser and let the light go through these two, because the laser is monochromatic, they will have exactly the same wavelength. Therefore, these two will have the same wavelength, and you will see, depending upon these have exactly the same phase, or they have the out of phase, you get bright and dark fringes. So now you can see the combination of interference and diffraction, because a little while ago I have mentioned that interference cannot exist independently, whereas diffraction can exist independently. This picture shows the central part. This is the 0th order of the diffraction. We'll be talking about diffraction in a minute. So this is the central portion within which we have the interference fringes. You can also see, and each one of these orders also, we have these interference fringes. Whereas you can easily see the envelope that is out, covering up all these interference patterns. This is the diffraction pattern, wherein the central intensity is very, very intense, and as we go on either side, this is called the first order, this is called the second order, the intensity goes down. We will be using something like this. This is called an interference and grating plate. These are very easily available and very inexpensive. They are practically available in every physics lab. So this will have a series of slots within which there are diffraction gratings. These diffraction gratings have got number of lines per meter. Of course, the inverse of that is a grating constant. So therefore, we can have a number of gratings with different grating constants. And then we also have a series of double slits with a different spacing between them. So these double slits we'll be using for interference, and these gratings we'll be using for the diffraction. So now this is the experimental setup for the interference. This is called also the Young's double slit experiment, in which you can see that light will be coming from two different points. You can easily see that the blue line is the shorter one, and you see the red line as much longer one. In other words, the red light travels much longer distance. So therefore, at the point when they meet, depending upon the phase relationship between these two things, we do have either constructive or destructive. It is important to remember that interference will always consist of constructive and destructive interference together. You can never have constructive interference alone, or you can never have destructive interference alone, because that will be against the law of conservation of energy.